Math 13-14, confidence intervals. Two types of estimates. We're about to get into the nuts and bolts of confidence intervals, but I want to do a little bit more generalizations, if you will, and talk about two types of estimates. The first type of estimate we'll be using is called a point estimate. The word point here is actually geometric in meaning. I'll show you what I mean when I draw a number line here in a moment. But a point estimate is a single value of a sample statistic. And by the way, the phrase sample statistic just means a variable that measures a sample, such as X bar or N. Actually, that wouldn't be a statistic. X bar or P hat. A single value of a sample statistic used to estimate a population parameter. Again, the phrase population parameter simply means variable from a population. So another way of saying this is a point estimate is a single value from a sample used to estimate a population. For example, the average salaries of employees at one school in a district is $30,000. We can interpret this as a sample because we're talking about one school in a district, presuming that there's more than one school. And I am fully aware that there are some districts that contain one school. I've worked at them. But let's assume here that the population is all the employees in the entire district, whereas the employees at this one school are a sample of all of the population's employees. So how can we interpret this as a point estimate? Well, we can say that that value, X bar, the average from a sample, equals 30,000, is a point estimate for the corresponding population variable. Well, if X bar is sample mean, then the corresponding population variable would be population mean, and that's mu. In general, X bar is a point estimator for mu. P hat is a point estimator for P. And again, the reason it's called a point estimate is because if we were to draw a number line, which doesn't have to have 0 in the middle, but let's just pretend that 0's over here, and then we have 20,000. Why 20? Oh no, why not? We go in increments of 20,000. Then where would 30,000 be? 30,000 would be a single point on this number line, hence the name point estimate. So just remember, a point estimate is a single value from a sample to estimate the corresponding value from a population. But we're going to be building interval estimates. An interval estimate is an interval of values centered at a sample statistic used to estimate a population parameter. So it's kind of the same thing, except we don't settle for a single value. We take a single value in the middle of an interval of values, and we look at that collection of values as the interval estimate. For example, in a sample of drive-through COVID test, 4.5% came back positive. Now, we could interpret this from a point estimate perspective by saying, well, this is a percent of a sample with a characteristic, so this is a proportion, but it's a proportion of a sample. So we're basically saying P hat equals 4.5%. And by the way, percents are great for describing things, horrible for doing math with. So in general, when you do math with the percent, you convert it to a decimal. So I'm just going to put comma or its decimal equivalent by moving the decimal 2 places to the left, 0.045. Both of those are correct values for P hat. And we could put them on a number line. But that's not an interval estimate. That's just a point estimate. To create an interval estimate, you think of a number line with a point estimate somewhere on it. Let's just put it in the middle, and we'll go back to leaving it as a percent for a moment. as a single value, it's a point estimate, but to create an interval estimate, we have to imagine stretching this out in both directions the same amount, and the amount would be called a margin of error. So if we have this point estimate, and I give you a margin of error, so let's say you use a margin of error of 0.5%, that means to create an interval, we have to go to that point and in both directions go whatever the margin of error is. So if we go to the left, 0.5%, and we go to the right, 0.5. Let me write those underneath. It's getting kind of crowded on the above that number line. A second here. There we go. So from the center, if we go to the left, 0.5%, and to the right, 0.5%, and we can calculate these endpoints of this interval. To calculate the left endpoint, we would have to simply subtract 4.5% minus 0.5% is 4.0%. And if we added 4.5% plus 0.5% is 5%, or 5.0%, if we want to preserve the number of decimal places. So our interval estimate, there's a variety of ways to describe this range of values. We could simply say the phrase from 4% to 5%. We could also write it in parentheses with a comma in between. This is not my favorite way of writing it. I prefer saying the phrase from 4% to 5%, but that's an example of an interval estimate. You have a value from a sample, but you also have a margin of error, or as we'll do later, you calculate a margin of error and use that to extend to the left and to the right of that point to create a left end and a right end of an interval of values. A confidence interval is an interval estimate, looks like in about 1, 2, 3 videos, we're actually going to start creating a confidence interval from measurements from a sample. But I got a couple more general concept videos, then we'll get down to building confidence intervals, or at least one type of confidence interval.